Hello, fellow yeast enthusiasts. I'm here today to talk about yeast interactions during wine fermentation. Winemakers usually add starter culture of the yeast Saccharomyces cerevisiae to ensure a good fermentation process. But the growing interest in using non-Saccharomyces, which show a great diversity in must, require to finally understand the interactions between the different yeasts involved in fermentation. The objective of my work was to determine how species and strain level impact yeast interactions. To do this, we compared coculture growth to monoculture in synthetic grape must for 24 hours. We studied 5 species commonly isolated in must, and for each species we selected 3 strains for a total of 15 strains. We monitored the growth of all possible pair combination by measuring the optical density in a plate reader. And we measured the proportion of both strains at inoculation and after growth, since one was tagged with GFP. When comparing to monocultures, we were able to identify 4 typical growth of cocultures. 2 cases of in-between growth. In case A, the coculture, so the black curve, is close to the average of both monocultures, while in case B, the coculture is closer to the better growing strain. And thanks to the population measure, we know that Torulaspora delbrueckii 3337 is the main strain present after growth, indicating that it outcompeted Starmerella bacillaris V81. In case C, coculture shows what would be similar to overyielding, since the overall growth, when considering the area under the curve, is higher than both monocultures. And in case D, we have underyielding, since the coculture growth is below both monocultures. To better evaluate the result of cocultures for all combination, we computed an interaction index which compared the growth of cocultures to the average of monocultures. When growth of coculture is higher than the average growth of monoculture, case B and C, the index is positive in green, whereas when the coculture growth is smaller compared to the average of both monoculture, case D, the index is negative in red. We can see on the heat map that interaction type is mainly determined by the 2 species involved. For instance, Saccharomyces cerevisiae shows positive index when in coculture with Hanseniaspora, uvarum, and Starmerella bacillaris, while it shows negative index with Lachancea, thermotolerans, and Torulaspora delbrueckii. On the contrary, Starmerella bacillaris always give positive index, and it's because Starmerella bacillaris is systematically outcompeted by the other species. Strain level was mainly impacting the intensity of interaction. To conclude, we've seen that the species rather than strain seems to be the main determinant in coculture growth. Moreover, as most interaction index were different from 0, it suggests that coculture growth is not additive, and so it is not predictable from monoculture's results. Further research will focus on the interactions between species in more complex consortia to understand whether coculture interactions are maintained even with higher order interactions.